It's the beginning of July. The hottest day of the year so far was about a week ago. It saw 500,000 people descending on beaches in Bournemouth. It's more of a typical British summertime at the moment. Camping weather, I call it, after many a long year under canvas listening to the soft patter of cold rain. There's lots of talk at the moment about global warming and climate change and a call to action. Recently, the government declared a climate emergency. We had the spectacle of Extinction Rebellion gluing themselves to tube trains. What I'd like to do today is to take a look at the science behind the headlines. Once we've done that, maybe then we can go save the world. Earthrise is a photograph of Earth and some of the Moon's surface that was taken from a lunar orbit by astronaut William Anders on December 24th, 1968 during the Apollo 8 mission. It remains one of the most famous photographs ever taken. It was the first time that people had seen the Earth in quite this way, and it changed the way people thought about it. The 1960s marked the beginning of the environmental movement, which is now more important than ever. At this time, when people asked themselves what the probable consequences of man's activity with respect to the environment might be, there was a theory called global dimming. Burning fossil fuels could lead to a build-up of soot and pollutants in the air, which could mean less sunlight got through to the Earth, resulting in the Earth becoming cooler. There were concerns that the Earth was heading towards a new ice age. It was the time of the Cold War, and Warsaw Pact and NATO forces faced off across the Iron Curtain with enough nuclear missiles to destroy the world 20,000 times over. If the 4-minute warning sounded, that was how long you had to live. It was MAD. MAD stood for Mutually Assured Destruction. Honestly, people were more concerned about that. Global dimming was a well-established idea. The year 1816 is known as the year without a summer because of severe climate abnormalities that caused average global temperatures to decrease by 0.4 to 0.7 degrees centigrade. Summer temperatures in Europe were the coldest on record between the years of 1766 and 2000. This resulted in major food shortages across the Northern Hemisphere. It was also the year Mary Shelley wrote the book Frankenstein. She was on holiday, and there was absolutely nothing that they could do, so she stayed indoors and wrote that novel. Evidence suggests that the anomaly was predominantly a volcanic winter event caused by the massive 1815 eruption of Mount Tambora in April in Indonesia. This eruption was the largest in at least 1,300 years. 160 million years ago, scientists believe a huge meteorite struck the Earth. It threw up a huge cloud of dust that blocked off the sun for years. Everything got much colder, plants could not photosynthesize, and almost everything eventually died. It marked the end of the Jurassic period. The dinosaurs, which had ruled the Earth for 100 million years, were gone. The path was clear for humans to evolve and take their place. Global dimming is the reduction in the amount of global radiance at the Earth's surface that has been observed since measurements began in the 1950s. The effect varies by location, but worldwide it has been estimated to be of the order of 4 to 20% reduction. Global dimming is thought to have been caused by an increase in particulates or aerosols, such as sulfate aerosols in the atmosphere due to human action. Obviously, it can also be caused by volcanoes. Global dimming has been attributed as the leading factor in the 1984 Ethiopian famine by reducing heating at the tropics, which drives the annual monsoon or wet season. The Indian Ocean brown cloud or Asian brown cloud is a layer of air pollution that currently covers parts of South Asia, namely the northern Indian Ocean, India and Pakistan. Viewed from satellite photos, the cloud appears as a giant brown stain hanging in the ocean over much of South Asia and the Indian Ocean every year between January and March, possibly also during earlier and later months. The term was coined in reports from the UNEP Indian Ocean Experiment. Global dimming creates a cooling effect that reduces the global average temperature by something in the order of 0.3 to 0.7 degrees centigrade. Globally, it should be more like 1816. In that year, this country recorded its lowest ever July temperature. In the aftermath of the 9/11 attacks in the United States, all commercial aircraft were grounded for at least 3 days. During that time, scientists were able to test the extent to which global dimming was taking place. They found global dimming was taking place. To better understand why the Earth is not getting colder, we need to look at how all of this works. Scientists have long known that the presence of an atmosphere keeps the surface of the planet warmer than it would be without an atmosphere. In fact, without an atmosphere, the surface of the Earth would be about 30 degrees cooler than it is now. We know that the Earth emits enough long-wave radiation into space to equal the solar radiation absorbed by it. This is known as the radiative equilibrium. This maintains the Earth at a constant temperature. Think of an electric fire heating a big, cold room. Eventually, the heat lost by the room will be equal to the energy supplied by the fire. The room will get to a certain temperature, but won't get any warmer. In order to understand why this is the case, we need to consider the surface of the Earth and the atmosphere separately. Shortwave radiation from the Sun hits the atmosphere. Most of it passes straight through and hits the surface of the Earth. However, some of this shortwave radiation is reflected directly off the atmosphere. Most of the long-wave radiation that is emitted by the planet into space is emitted by the atmosphere rather than the surface of the Earth beneath it. Although the surface of the Earth does emit long-wave radiation, only about 10% of this radiation passes through the atmosphere. The rest is absorbed by clouds and greenhouse gases in the atmosphere. There are many greenhouse gases, but the most abundant greenhouse gases are water vapor and carbon dioxide. Short-wave radiation from the Sun passes through greenhouse gases, but long-wave radiation is absorbed by them. Greenhouse gases absorb long-wave radiation that is emitted by the surface of the Earth. They then re-emit the energy as long-wave radiation in all directions. About half of the re-emitted long-wave radiation does escape into space and contributes to the radiative equilibrium. About half of the long-wave radiation emitted by the gases is directed back towards the surface of the Earth. As a result, a continual exchange of long-wave radiation takes place between the surface of the Earth and the atmosphere above it. The long-wave radiation contained in this exchange causes the greenhouse effect. The phenomenon is known as the greenhouse effect because, like the glass in a greenhouse, the atmosphere traps some of the energy beneath it. The greenhouse effect produces a warmer climate on Earth than would be possible without an atmosphere. In summary, water vapour and carbon dioxide allow solar energy to penetrate Earth's atmosphere, but prevent much of the long-wave radiation emitted by the surface of the Earth from escaping into space. This trapping of long-wave energy is called the greenhouse effect and enhances the surface temperatures of the Earth. When pollutants like soot and sulfur from volcanic eruptions get into the atmosphere, less global radiation reaches the Earth. More radiation is reflected directly from the atmosphere and the Earth becomes cooler. So why is it getting hotter? This is Australia at the beginning of this year. Australia experienced record temperatures and bushfires raging out of control. In some parts of Australia, this was followed by flooding and then snow. So clearly there are factors other than global dimming and the greenhouse effect involved. Climate is not the same as weather. Weather is the state of the atmosphere at a given time and place. It is measured in terms of factors such as temperature, rainfall, humidity, and cloudiness. Climate is the average weather for a region over a long period of time, usually 30 years. Weather can change several times a day. The climate normally takes a long time to change. Systematic recording of weather data has only occurred since the 19th century. These and other records have shown that the climate does naturally change over time. For example, paintings and diaries provide information about the Little Ice Age. This was a period of cooling from about 1300 to 1850. Many glaciers increased in size, crops were lost, and major rivers such as the Thames regularly froze. Before the Little Ice Age, there was an unusually warm period known as the Medieval Warm Period, which lasted for about 8 centuries. And then there were particular years. 1816 was particularly cold, as was the extreme weather events of 535 AD. Global warming. This is a graph produced by NASA showing the temperature change in the last 50 years. It compares the years 1951 to 1978 with 2010 to 2019. The highest temperature change we can see is in the Arctic, shown in red, with temperature changes of more than 4 degrees centigrade. This country shows a temperature increase of around 2 degrees centigrade. Compare that to 1816, the year without summer, It was about 0.4 to 0.7 degrees centigrade. What is global warming? Global warming is the ongoing rise of the average temperature of the Earth's climate system. It is a major aspect of climate change, which, in addition to rising global surface temperature, also includes its effects, such as changes in rainfall. While there have been prehistoric periods of global warming, observed changes since the mid-20th century have been unprecedented in the rate and scale. What causes global warming? Burning fossil fuels and man's activities produces carbon dioxide and other greenhouse gases. These go into the atmosphere. Short-wave radiation from the sun passes through them, but long-wave radiation directed back up from the Earth's surface does not. They absorb the radiation and re-emit it in all directions. This is the greenhouse effect. We looked at this last time. The more greenhouse gases there are, the less radiation is emitted from the atmosphere into space. This will increase the global temperatures. Should we be worried about global warming? Higher temperatures cause seawater to expand and ice to melt, causing sea levels to rise. It has risen a little bit over the last 100 years. If it keeps rising, it will be bad news for people and animals living in low-lying places. It will lead to flooding, resulting in the loss of habitats. The distribution of many wild animals and plant species may change as temperatures increase, and the amount of rainfall changes in different areas. Some species may become more widely distributed. For example, a species that needs warmer temperatures may spread further as the conditions they thrive in exist over a wider area. Other species may become less widely distributed. For example, species that need cooler temperatures may have smaller ranges as the conditions they thrive in exist over a smaller area. There could be changes in migration patterns. Some birds may migrate further north as more northern areas are getting warmer. Biodiversity could be reduced if some species are unable to survive a change in the climate, so become extinct. How hot can the greenhouse effect get? Well, the planet Venus is further from the Sun than Mercury, but has a higher average temperature. Its surface can reach up to 482 degrees centigrade, which is hot enough to melt lead. Venus's atmosphere is mostly made up of carbon dioxide, which traps so much of the solar radiation that the planet becomes extremely hot. The hostile climate conditions on Venus make it impossible for life to survive. Well, what about global dimming? At the same time that we have global warming due to an increase of greenhouse gases in the air, we also have global dimming due to pollution in the atmosphere. We know this. If we didn't, we have the Indian Ocean brown cloud covering parts of South Asia to remind us. Not as much solar radiation reaches the Earth. Despite this, the Earth is still warming up. This means the effects of global warming are worse than we think. Following 9/11, when commercial aeroplanes were grounded, scientists studied the effects of global dimming and were able to observe the opposite phenomenon, or global brightening. Let me give you another example, more recent. People in the northern Indian state of Punjab are reacting with awe at the sight of the Himalayan mountain range, which is now visible from more than 100 miles away due to the reduction in air pollution caused by the country's coronavirus lockdown. Indians in the city of Jalandhar and the surrounding area have posted photos online of the views from their homes, with some saying they haven't seen the peaks of the Himalayas for decades. I think you can see from those pictures global dimming and global brightening. What is climate change? Climate change is a natural phenomenon and normally takes place over several centuries. The term climate change is being used now to refer to the current climate. This is because recent scientific records show that the global climate seems to be warming up more rapidly than usual. For example, 18 of the last 19 years have been the warmest in recorded history. So what happens when fossil fuels are burned? Fossil fuels are carbon-based materials that formed over millions of years from the remains of ancient plants and animals. Fossil fuels are burned to generate heat. In power stations, in cars, this combustion creates carbon dioxide and water as waste products. Greater use of fossil fuels is thought to be the main source of the increase in atmospheric carbon dioxide. Carbon dioxide is considered the most significant greenhouse gas. This is because carbon dioxide can remain in the environment over a long time, from 50 to 200 years. Any process producing carbon dioxide today could affect the climate for hundreds of years. Carbon is present in all living things and moves through the environment in a chain of reactions called the carbon cycle. So what else affects greenhouse gas levels? Burning wood releases carbon dioxide into the atmosphere. Living trees also have a major impact on the atmosphere as they produce oxygen and absorb the greenhouse gas carbon dioxide. Deforestation reduces the amount of photosynthesis taking place and so increases carbon dioxide levels. Rice farming and cattle farming produce the greenhouse gas methane. This gas is 7.5 times more effective as a greenhouse gas than carbon dioxide, but is currently in the atmosphere at much lower levels. Atmospheric carbon dioxide levels are measured around the world to detect global trends in this greenhouse gas. The standard measurement used is parts per million. The global average atmospheric carbon dioxide in 2018 was 407.4 parts per million. Carbon dioxide levels today are higher than at any point in at least the past 800,000 years. Research stations for monitoring atmospheric gases are usually sited in remote places. This one is in Hawaii. Ice cores are long columns of ice that are drilled out of glaciers. Ice cores are studied to increase understanding of the history of climate as they provide data about the distant past. Air bubbles trapped in the ice are used to estimate carbon dioxide levels thousands of years ago. This is called a proxy record. These are indirect climate measures of the climate that have not been recorded using instruments. Tree rings are another type of proxy record. This is data collected from the Greenland ice sheet. If you look at the graph at the bottom on the right, you can see temperature increases. Data collected by climate scientists can be used to answer two key questions. Is the climate really changing rapidly? And is human activity causing this climate change? These graphs show how carbon dioxide concentrations have changed over time. Around 200 years ago, carbon dioxide levels were about 280 parts per million, and now about 407 parts per million. I think that was in 2018. The global average temperature has increased at the same time as the levels of carbon dioxide have risen. So if you compare those two graphs, you can see that as the rate of carbon dioxide has increased, the temperature has increased. We say that there appears to be a positive relationship between carbon dioxide levels and temperature. It could be that the carbon dioxide levels have increased because the temperature has increased, or the temperature has increased because the carbon dioxide levels have increased. You need to be very careful how you look at data. Scientists use experiments to explore how things work and test predictions. However, the climate is far too large and too complicated to be reproduced in a laboratory. Instead, computer models are used to represent the climate and explore the possible effects of human actions. Mathematical formulae are used to represent the separate parts of the climate system and how they interact. And nowadays they use supercomputers because climate modelling is really complex and difficult. This was the guy who first came up with it. Climate modelling evolved from a formulae used for weather prediction. These were created by Lewis Fry Richardson, an English mathematician. When his work was published in 1922, the predictions were not very accurate because the calculations took a long time. Richardson thought a whole half full of people working on the calculations would be needed to keep up with the weather. What he really needed was a supercomputer. Okay, so how accurate are our climate models? Well, there's some skepticism about the accuracy of the predictions using climate models. Climate models do not measure local variability well, and it's difficult to model some things like clouds. Cloud cover greatly influences surface temperatures. Not including clouds in models could reduce their accuracy. And to predict the contribution of humans to climate change, the models have to make assumptions about populations and economic growth. Using data from several key sources, International Panel on Climate Change, or the IPCC, have made the following projections about climate change. It says we'll have an increase of 1.5 degrees. Anyway, it could be 3 degrees if we do something about it. Even assuming full implementation of conditional and unconditional nationally determined contributions submitted by the nations in the Paris Agreement, people have already pulled out of the Paris Climate Accord. It's basically saying that global warming is not going to be less than 1.5 degrees. Some effects of climate change may not take place for decades. The precautionary principle advises that a lack of scientific certainty is not an argument against taking action when there is a serious threat. This can be applied to climate change. If predictions about the human impact on climate change are correct, the results will be widespread and devastating. Rising sea levels would flood many major cities. Decreasing rainfalls in Africa could affect 70% of the continent's population, leading to widespread famine. If we delay taking action, it is likely to become impossible to avoid or reverse these climate changes. So when did it become an emergency? Maybe it became an emergency when we realised that it was a global problem that world leaders would have to work together to solve, something they've never been very good at doing. Maybe it became an emergency when people realised that they would have to rethink the lives they were living and the whole system needed to change to help them. Maybe it was when the young finally decided that they did care, and with their whole lives in front of them, that the future could be whatever they imagined. But it brings us to this precise point in time. And if the COVID-19 crisis has taught us anything, it is that when we need to, we can alter the way we live. And whether it's the coronavirus or the environment, there's no time quite like the present.